Good morning, class. We're going to cover proofs and basically the introduction of proofs. So I'm going to go through the book. I'm sorry we don't have a PowerPoint for this. We will have a PowerPoint on Monday, Tuesday for class. So as we go through this, I'm just going to talk through points, and it will probably be a 20-minute video, but class will actually meet earlier for the Zoom. Okay, so class will meet like 10 to 20 minutes earlier today. Okay, so postulate or an axiom is a statement that's written without proof. It's just something true we base everything on. And this is actually a fascinating part about a lot of things we hold. We actually have postulates inside us. When we understand things, there's key terms, key ideas that we just accept as true. Everything else we base off of those, and the other things require evidence. So here's some of our postulates. You should know these. They're stuff we've already covered. So 2 points, there is exactly one line. There are any 3 non-collinear, there's one plane. A line contains at least 2 points. A plane contains at least 3 non-collinear points. 2 points lie on if 2 points lie on a plane, then the entire line containing those points lies in the plane. 2 lines intersect. Their intersection is exactly 1 point. 2 planes intersect. Their intersection is a line. Okay. Key postulates. There's examples here in the book. You should know them. Real world examples. We're going to actually skip this example. We are going to then look at the worksheet real quick to talk about this. So I'm going to load this up so that we get the full picture. Okay, we're going to have, worksheet. Let's look at which postulates do we have? Postulate. So we're answering 1. So we determine whether each statement is always true, sometimes true, or never true. Always true means it's a postulate. Sometimes true means it might happen sometimes, and never true means this is a line contains exactly 1 point. Always true, sometimes true, never true. Non-collinear points, R, S, and T, are contained in exactly 1 plane. So always true, sometimes true, never true. Any 2 lines, L, M, intersect. Any 2 lines, L and M, intersect. If points G and H are contained in plane M, then G and H is perpendicular to plane M. Plane R and S intersect at plane T. If points A, B, C are non-collinear, then segments A, B, B, C, and CA are contained in exactly 1 plane. 2 points A, B are determined a line. Okay? So always true, sometimes true, never true, and explain why. Now, always true will be a postulate. Sometimes true might be based on a postulate, but it won't necessarily be. And never true is the opposite of, it's counter to what we've learned in our postulates. Okay? So we're going to come back to this. That's within. We'll talk about these later. Okay, so we'll come back to them in class. Okay, when we do problems, we actually in algebra base a lot of our thoughts off of things we have already come to accept. So example of this is when you do addition, you already use properties in your brain. Properties that help you do the math. And so we accept these properties because, like we just said, these properties are our basis for how we can do this math. Just like that, in geometry, we are going to use properties. But the thing is, we're going to prove them through a reasoned argument, okay? Now the reasoned argument is what we would call a proof. So a proof, mathematical proof, is a logical argument in which each statement you make is supported by a statement that is accepted as true. So there are two kinds of proofs you will learn: a flow proof, which uses boxes and arrows to make logical progression, and then a second proof, which is a paragraph proof, okay? Also called informal, but that's not because it's not informal, but just it's just it is not necessarily algebraic or like a flow trait. Okay, so flow proof. If we were to look at a flow proof, we can see an example right here. So we start with a given. Let's zoom in a little bit. Apologies. So with a flow proof, we start with our given. So prove that this y plus 2 over 3 equals 3. Then y equals 7. Okay? So the first step is we use a multiplication property, right? We multiply both sides by the same number. That is a multiplication property of equality. Okay? Right there. Then, after that, we multiply it, and then we use substitution. So substitution property is that you can, well, once you've multiplied, then you're going to substitute or subtract 2 from both sides. So when we subtract 2 from both sides, we get y equals 7. Okay? So substitution, I think, just means that we can replace it. So we replace equality. So 3 times 3 and 3 times divided by 3. Okay. So this is how to write a flow. Okay. Step 1, write the given statement in the box word given underneath. Step 2, create a deductive argument by forming a logical chain of statements linking the given to what you are trying to prove. Write the statements linked in the box, justify each statement with a reason written beneath the statement. Step 3, state what it is you'll prove. Okay, that's the flow proof in our worksheet. We actually have. This is the postulates. 2 is still postulates. 3 is still postulates. 4 is writing flow proof. We're going to do this in class. You can do it yourself. You have to make sure you state which postulates you use. So it's going to be these postulates right here, key ones with real numbers. Okay. So use those underneath. State which property you're using. You don't have to say of equality. Just say addition properties. Say addition, subtraction, multiplication, division, reflexive, symmetry, transitive, substitution, distributive. Okay. Okay. So that's going to be a flow proof. Flow proofs work really well in algebra. Geometry, we're probably going to go to a different thing. Okay, a theorem. So once a statement or conjecture has been proved, it is called a theorem. So once you can prove something through your postulates, that statement is a theorem. It can justify other proofs, so it kind of builds. Think of, apologies, this camera is going to keep falling. So our building blocks are going to be our postulates, okay? And once they build together, this bigger structure is going to be what we call this whole thing leading to its conclusion is going to be a theorem. Okay? We can then use this block in the future without having to prove it. Okay? So we use postulates, we come to a conclusion, right? Therefore, now we can use this theorem to build others, okay? Right, to build to other theorems. Right, so theorem 1 can lead to theorem 2 and so on, right? Okay, so it can lead, you can lead through, okay? Okay, so I want you to know that definition of theorems. And yes, we'll come back to this video later. Okay, we'll talk about paragraph proofs, and then we'll have, yeah.